So on Thursday last week, we talked about how to add rational expressions that do have a common denominator. Now we're going to start talking, and we'll be talking all week about how to add rational expressions that do not have a common denominator. Okay? So what we're going to talk about here, when we're dealing with rational expressions, again, that's a fancy way of saying polynomial fractions, and we want to add two together that do not already have a common denominator. That is going to follow the exact same process as if we were adding two fractions that do not have a common denominator. So those steps are relatively simple. What we need to do is we need to figure out what is the common denominator. We need to multiply each fraction by what factors of that common denominator are missing. And then we need to add the numerators together. So let's consider this problem here on the screen, 3/5 plus 8/3. The common denominator there would be 15. So we would need to alter this problem so that both of these fractions were over 15. We need to get that common denominator. So that would be our least common denominator, would be 15, which means our first fraction, we need to multiply the bottom of the fraction by 3 to turn it into 15, which means we also need to multiply the top of that fraction by 3 to turn it into to keep it the same, to not break the rules of math. So multiply the bottom and the top of that first fraction by 3. That turns 3/5 into 9/15. We do the same thing with the second fraction. We multiply the 3 on the bottom times 5, and whatever we do to the bottom of the fraction, we have to do to the top. So that fraction will become 40 over 15. Then we would simply add those two fractions together. We would add straight across. 40 plus 9 is 49 over 15. And then our last step, which isn't really written there, and so we should probably add it, is we are always required with any fraction problem to reduce if possible. And in this case, it is not possible. So we don't need to worry about that. Our answer would just be 49 over 15. Now, it wouldn't matter whether this was regular fractions like what we're looking at now, or rational expressions where the top and the bottom are polynomials, monomials, whether they have 18 variables. None of that matters. The process is still exactly the same. So we're going to do those 4 steps that you see up on the screen right now. We're going to find the common denominator. We're going to multiply the fractions so that they have that common denominator. We're going to add the numerators together, and then we're going to check and see if the fraction can be reduced. So let's do one here. Actually, I can fit 2 on the screen, so we'll do 2. Okay, so if we look at these two fractions, 5 over x and 9 over 4x, it should become readily apparent to us that those are not already a common denominator. However, the common denominator should be relatively easy to figure out. In order to have a common denominator, we need to include the common denominator for the coefficients, which are 1 and 4. So that number would be 4. And we need to include every variable that's there. So we would need our common denominator to be 4x. So that first fraction, we needed to multiply the bottom by 4 in order to turn it into 4x. And whatever we do to the bottom of that fraction, we also have to do to the top. And that 4 is terrible, so let me try that again. So 5 times 4 would give us 20 over 4x. The second fraction already has 4x for a denominator, so we don't have to do anything to that. We just rewrite it as 9 over 4x. And then we would just add those together. 20 plus 9 is 29 over 4x. We check to see if that can be reduced, which it cannot, so that is our answer. Again, at any time, if you have questions, just drop them in the chat. I'll be happy to answer them. Otherwise, we're just going to keep going through examples. Once we get through enough examples that I feel comfortable, we'll talk about how we're going to get the new platform up and running, which is going to require you guys to sign up on a website. I think it's a good idea, so we're going to do it. If you're not comfortable doing that, we can come up with an alternative assignment on IXL because you all already have that. So Let's move on to the next one there, 8x and 7x. Now they both have an x, so our common denominator will contain an x. But we need to figure out the numeric portion of the common denominator. So we need to think to ourselves, 8 and 7. What is the least common denominator if the denominators are 8 and 7? Well, 8 and 7 don't have any common factors. So the smallest number that would work would be 8 times 7, or 56. So our common denominator is going to be 56x. So we need to think to ourselves, okay, what do we need to do to each of these fractions to turn the bottom of those fractions into 56x? The first fraction, we need to multiply the bottom and the top by 7, which would give us 21 over 56x. The second fraction, we need to multiply the bottom and the top by 8, which would give us 64 over 56x. We would then add those two together. 21 plus 64 is 85 over 56x. We quickly check to see if there are any common factors. There are not, so that does not reduce. Again, at any point, if you have questions, drop them in the chat. Otherwise, we're going to keep on moving forward. If you want to take a screenshot before I change the screen, please do so now. We've got about 10 seconds or so until I rotate down to the next couple of examples. Okay, so here's a couple more. Well, here's one more. We'll fit this one more on the screen. We'll do this one. Here, our common denominator would be 2 times 3, or 6. So the first fraction, we need to multiply the bottom and the top by 3, which would give me 21x. The second fraction, I need to multiply the bottom and the top by 2, which would give me 16 over 6. Now, this one is a subtraction problem, but that is no different from addition. It just means instead of adding the numerators, we subtract the numerators. So 21x minus 16. Now, don't be that guy that turns that into 5x, because you can't do that. 21x minus 16, those are not like terms. So what we end up doing is we just leave that as a binomial, 21x minus 16 over our common denominator of 6. And once again, we would check to see whether or not that is reducible, but it's not. 21 and 16 don't have any common factors, so we can't factor anything out. They're not all even, so we can't divide by anything. There's nothing we can do to reduce that fraction, so we just combine them into a singular fraction, 21x minus 16 all over 6. All right, let's move to the next couple. Should be able to fit 2 on the next page here. Again, if you have any questions, drop them into the chat and I will answer them. We are going to move on forward here. So here's 2 more, well, 3 more. We're only going to do 2 on the screen right now. Okay. So on this next example here, our common denominator would be 5x. Which means we only need to adjust the first fraction because it is missing an x. That would give us 3x over 5x for our first fraction. Our second fraction would not change. It would stay 7 over 5x. Again, those numbers, 3x and 7, can't actually be added together because they're not like terms. So we would simply write that as a single fraction, 3x plus 7 over 5x. And again, there are invisible parentheses around that top, so we can't like cancel that x. That's not allowed because those parentheses are protecting 3x plus 7. So that would be our final answer. That's as good as that's going to get, 3x plus 7. And again, this is our first day talking problems that do not have a common denominator. So I'm trying to keep it as simple as I can. This will take a definite step up in difficulty when we discuss it on Thursday and we talk in more detail and we talk with harder problems. So on the next problem, our common denominator would be 9x to the second power. So again, we're missing an x on that first fraction. So we would multiply the first fraction by x, which would turn it into 7x over 9x squared. And the second fraction is already what it needs to be. It's already over 9x squared. So we wouldn't need to do anything to that second fraction, just rewrite it. We combine those. Once again, 7x and 8 are not like terms, so they can't actually be added, which means our answer would be 7x plus 8 over 9x squared. So there's two more. Again, if you're grabbing screenshots, now would be the time to grab one before I go to the next portion of this thing and move those off of the screen. Again, if you have questions at any time, drop them into chat, okay, and I will answer them as we go. And if you haven't sent me your name yet, you need to drop your name to me in chat so that I know you were here. Okay, a couple more examples. I think we can fit 3 of these on the screen here. We'll just fit 2 and we'll make that work. So again, this is just more of the same here. We need to figure out what our common denominator would be, in this case 8x squared. Then we need to multiply the fractions by whatever's missing. So the first fraction needs an x. The second fraction does not need anything. It's already a 1 over 8x squared. And then we go in and we combine those two fractions by adding or subtracting the numerator, in this case subtracting, and we leave the denominator alone. That's all there is to this, and it's not recreating a wheel here. This is something that in theory you should have discussed in Algebra 1. The question is whether or not your Algebra 1 teachers made it that far, because this is relatively late in the year Algebra 1, just like it's relatively late in the year Algebra 2. So you may not have made it to it. Okay, so we've got a question, so if you just drop that in chat for me, I can do my best to get it answered. Okay. Yes, we're only, in that example, we only need to add an x to the first fraction. The second fraction already has our common denominator. What we're doing is we're adjusting each fraction so that the denominator matches the common denominator. So we're multiplying by whatever's missing. In some cases, that'll be just one fraction. In other cases, it'll be both fractions. It just depends on the problem and what those denominators are. So like here on this one I'm about to start, the common denominator is going to be 3x because we have to have the 3 and we have to have the x. That second fraction already has that common denominator right there. So we don't need to do anything to the second fraction. It's already good to go. All we have to do is just copy that one, 8 over 3x. But the first fraction, that one is missing the x. So we need to multiply the bottom and the top by x so that the denominator will match our common denominator, if that makes sense. So the only thing that'll change between the first and second steps of the example we're on is that the first fraction, to get a common denominator, we need to multiply the bottom and the top by x. So that'll give us 5x over 3x plus 8 over 3x. We add those together. Again, they're not common factors. So we would end up with 5x plus 8 over 3x. Now again, you need to keep in mind that we'll always have to check and make sure there are no common factors. It is rare that one of these will reduce after you solve it, but it can happen. It is possible that you would then have to reduce your answer. So you always need to check your answer to see if it can be reduced. I'm going to scroll down and put what I believe are the last two examples up on the screen here. So if you want a screenshot, grab one now Did that get the question answered? Again, it completely depends on what problem you're doing, how many things you have to multiply. Sometimes it's only one fraction, sometimes it's both fractions. So we've just got to keep an eye on what the problem itself is requiring you to do to get a common denominator. All right, last couple examples here. So on this next problem here, this is an example of where we're going to have to multiply both fractions to get a common denominator, because the common denominator for 6 and 7 would be 42. Now, what that means is that we have to actually multiply both fractions, not just one of them, which is the question that just came up a minute ago, I believe, assuming that I had it correctly. To turn 6 into 42, we need to multiply 6 by 7. Whatever we do to the bottom of that fraction, we also have to do to the top. So our first fraction is going to become 35x. Our second fraction, we need to multiply the bottom by 6 to turn it into 42. So we have to do the same thing to the top. And 4 times 6 would give us 24x for the second fraction. Then we would add those numerators together. Well, 35x and 24x, those are like terms. So we are really doing 35 plus 24, which would be 59x over 42. We check to see if there are any common factors, which there are not, because 59 is a prime number, so it is not divisible by anything that 42 is also divisible by. But you do have to check. You have to make sure that this fraction does not reduce. It does not, so that's our final answer. Okay, final example, and then we will work on getting signed up for our new platform that I'd like to use. So here we're looking at a common denominator. We'll have an x in it because we need to have that x, and the common denominator for 9 and 8 would be 72. So we're looking at 72x for our common denominator. That means our first fraction, we need to multiply it by 8. 5 times 8 would give us 40 over 72x. Our second fraction, we need to multiply that by 9. 9 times 9 would give us 81 over 72x. We would then subtract 40 minus 81 to give us negative 41 over 72x. Quick check to make sure that that fraction does not reduce, which it does not. And that would be our final answer. Okay, so that does it for the notes. What I'd like to do now is I would like to go through how to sign up for our new platform that I want to use. Okay, so let me stop the video real quick.